What if every drop of water on Earth simply vanished for 24 hours? No oceans, no rivers, no rain. Just gone. Let's set the rules first. This isn't a drought. It isn't a heat wave. Every molecule of liquid water disappears at once, everywhere, for exactly 1 day, then returns. Sounds survivable, right? 1 day, you've gone without water before. But here's what the science actually says would happen, and it starts faster than you think. The moment goes global, instantly. Oceans covering 71% of the planet's surface simply aren't there anymore. According to NOAA, the world's oceans hold roughly 96.5% of all water on Earth. Remove that, and you don't just lose beaches and fish. You lose the planet's single largest heat reservoir. Oceans absorb and slowly release enormous amounts of solar energy, keeping coastal regions mild. Take that away even for a day, and coastal temperatures begin swinging wildly within hours. Cities like Miami, Mumbai, and Tokyo would feel the air turn strange almost immediately. Dry, sharp, wrong. Now think smaller. Think personal. The human body is not solid. It's a water-based machine. Research by physiologist H. Mitchell in the 1940s established that the average adult body is about 60% water. Your blood, your muscles, your brain, nearly 75% water by weight. So what happens when the water already inside you starts running the show, with none left to replace it? For the first few hours, honestly, not much changes. Your body holds a reserve. But by hour 6, cells across your body already begin pulling moisture from wherever they can find it. Saliva production drops, your mouth turns dry, your blood volume dips slightly, and your heart starts working just a little harder to move it. Your kidneys shift into conservation mode almost immediately, concentrating whatever fluid remains and holding on to every possible drop. This is stage 1. Uncomfortable, but manageable. Athletes, outdoor workers, and anyone in a hot climate would feel it first. Their bodies already primed to lose moisture through sweat, with absolutely nothing left in the environment to replace it. Stage 2 begins around hour 12, and this is where it gets serious. Every plant on Earth relies on a process called transpiration, constantly pulling water from soil and releasing vapor through its leaves. With no water anywhere, including underground, that process halts instantly. Crops begin wilting. Not from heat, from the total absence of anything left to draw on. Farmers watching their fields would see visible stress within half a day. Could an entire planet's food system really buckle in 12 hours? According to agricultural researchers, most staple crops show measurable wilting after just 6 to 8 hours without any accessible water. So yes, easily. Rice paddies, already shallow pools of standing water, would be the first fields to visibly change, turning from glistening green to cracked brown almost in real time. Livestock, too, would grow restless within hours, instinctively searching troughs and streams that no longer hold anything at all. Meanwhile, something even stranger unfolds in the sky. Clouds are made of water. No water, no clouds. Skies worldwide would turn a flat, eerie, uninterrupted blue or black, depending on the hour. No rain is coming, obviously, but also no humidity, no fog, no morning dew. Meteorologists studying atmospheric water vapor estimate that water vapor makes up a small but critical percentage of the atmosphere, and losing it would immediately change how sunlight interacts with the air, making daytime skies feel harsher and nighttime temperatures drop faster than normal. Without moisture to trap and redistribute heat, deserts would grow briefly colder at night, while cities that depend on humid air to soften the sun's intensity would bake under an unfiltered glare. Even the color of sunsets would shift, losing the soft haze that water vapor normally scatters across the horizon. Now we reach stage 3, hour 18, and this is where the real danger sets in for people. Without water to drink, dehydration accelerates. The National Academies of Sciences estimates that a person can typically survive 3 to 5 days without water under normal conditions, so 24 hours alone wouldn't be fatal for most healthy adults. But normal conditions assume you still have water in your environment, in the air, in food, in your surroundings. This scenario removes all of it, everywhere, simultaneously. Combine that with no ocean regulating temperature, no rivers cooling cities, no moisture in crops or soil, and the compounding stress on the body multiplies fast. Hospitals relying on water-cooled systems would face immediate operational strain, and so would the patients inside them, since IV fluids and dialysis machines depend entirely on water that no longer exists. Power plants that use river or ocean water for cooling, a method used by a majority of thermoelectric plants worldwide, according to the U.S. Geological Survey, would begin overheating and shutting down within hours, threatening electricity itself. And once electricity falters, refrigeration, communication, and water treatment systems waiting to spring back to life at hour 24 would face their own separate crisis entirely. So picture it now, all at once. Global temperatures swinging unpredictably, crops collapsing across every continent, power grids failing as cooling systems run dry, and billions of people growing thirstier by the hour with nothing, anywhere, to reach for. Not a faucet, not a bottle, not a puddle, just dry air and dry ground, everywhere, for one single day. Then, right as the crisis peaks, hour 24 arrives. And water returns, all at once. Oceans refill, rivers flow again, rain clouds reform. But here's the twist nobody expects. The sudden return might be almost as dangerous as the disappearance. Dehydrated soil, unable to absorb water gradually, would trigger instant flash flooding in regions with cracked, hardened ground. Hydrologists know this pattern well from real droughts. Ground that dries out too quickly becomes almost waterproof, shedding rainfall instead of soaking it in. Rivers refilling in seconds rather than gradually would surge violently through dry riverbeds, catching entire towns off guard. Coastal areas would see waves crash back into place with sudden disorienting force. The very relief the world is waiting for would arrive like a tidal wave, literally, and in some places, just as destructively as the drought itself. We've actually seen a smaller version of this play out in real life. The Aral Sea, once one of the largest lakes on Earth, was drained down to a fraction of its size over decades due to river diversion projects in the 20th century. Researchers studying the region found that even that slower, partial loss of water devastated local climate, agriculture, and health for millions of people, and it happened over years, not hours. Local temperatures swung more sharply, dust storms carrying salt and chemical residue spread across neighboring regions, and fishing communities that had thrived for generations collapsed almost entirely. Now imagine that effect, compressed into a single day, at planetary scale, hitting every coastline, every farm, every city, all at once. So would the world survive 24 hours with zero water? Probably. Barely. Scarred, but standing. Yet the same substance we rarely think twice about, sitting quietly in oceans, clouds, soil, and our own bodies, turns out to be the single thread holding the entire planet's systems together. Not gold, not oil, not electricity, water. So the next time you turn on a tap without a second thought, remember this. What if every drop of water on Earth simply vanished for 24 hours? Now you know. It wouldn't take a war, or an asteroid, or a nuclear winter to bring civilization to its knees. It would just take one missing ingredient, the one we've always had, the one we've never really had to imagine losing, sitting quietly in every glass, every cloud, every living cell, waiting to remind us how much we depend on something we almost never think about at all.